Hello and welcome to the video lesson on factoring binomials. Binomials have a specific and different way to factor than other types of polynomials, and so there's a video lesson just on that. So just like with any polynomial, the first thing to do is always to look for, and if there is one, pull out or factor out a common factor. So you're always looking at all of the terms of the polynomial to see if there is a common factor, and then you'll take out the greatest common factor. In a binomial, there are only two terms. You're checking to see if both terms share a common factor. After you have done that, in order to continue, the binomial must be a difference of squares. The word difference in math means a subtraction. So what that means is that there's a perfect square minus another perfect square. If you have that, and only if you have that, this is how that factors. So if you have a perfect square, the square root of that first term minus the square root of the second term times the square root of the first term plus the square root of the second term. It's really important, and this only works with a minus, because when you FOIL this, when you double distribute this out, the middle terms of your distribution cancel. And that's something that we will look at or have looked at in class. But the math way of writing this is to say that if you have a perfect square minus a perfect square, this factors as the square root, so without the square, minus the square root times the square root plus the square root. So I'll show you a couple of examples to see how that works. So what I would do first is look for a common factor. Here, there isn't one. There are two terms I want to check or verify to make sure that it is a difference of squares. X squared is a perfect square. It's x times x. And 9 is a perfect square, 3 times 3. And it's a difference because there's a minus between them. Once I have verified this, this is how this factors. So the square root, or the identical factors of x squared, are x and x. And the identical factors of 9 are 3 and 3. So that x, the square root of x squared, that goes here and here. Those are the square roots of the first term. I always have this template with the 1 minus and the 1 plus. And the identical factors of 9 are 3. The square root of 9 is 3. Those go here and here. So I have x minus 3 and x plus 3. If I were to check what would happen if I multiplied this out, I'd get x times x, x squared, plus 3x, minus 3x, those cancel, and then negative 3 times 3 is minus 9. So it works. The one thing to note here is that the order of the brackets, which one has the minus and which one has the plus, it doesn't matter which one comes first, because you're multiplying them, the order of multiplication doesn't change anything. If you'd like to give this one a try, I recommend pausing the video for a minute, see if you can factor this. But I'm going to go ahead and go through the same questions. Is this a difference of squares? And is there a common factor? So first, common factor, no. Second, 36, x squared is a perfect square. Y squared is a perfect square, minus between them. Check, check, check. So the way I would factor this is the square root of this, which is 6x, and the square root of this, which is y, are going to be my two factors, one with a plus and one with a minus. Next example, you can pause if you like. The square root of 9x squared is 3x. The square root of 1 is 1. There's a minus between them. This is how it factors. So far in all of the examples that we've done, there has not been a common factor, but this one does have a common factor. And even though 2x squared isn't a perfect square, and 50y squared isn't a perfect square, because I have to look for a common factor first, when I factor that out, I am left now inside the brackets with a perfect square, and a minus between them. So again, if you want to pause for a minute to see if you can factor this, go ahead. I'm going to skip ahead to the answer. That common factor remains outside the double set of brackets. That's still part of the problem because the original was still multiplied by 2. Now in a case like this, if I look for a common factor, there is one. So I would start by taking out my common factor. Both are divisible by 4. Now here, when I'm verifying, x squared is a perfect square. 9 is a perfect square. But there's no minus between them, which means this is not a difference of squares. And I can't factor a binomial that isn't a difference of squares. So that's it. This is the most factor this gets. And finally, the final thing to say about this, sorry, I'll skip over this last example real fast. The last thing to say about this is that it is possible that once you factor something, one of your factors is factorable. So there's no common factor here. This is a perfect square. This is a perfect square. I know that this is a perfect square not because 4 is a perfect square, but because for variables with exponents, I have to be able to divide them by 2. But this, x squared, is the square root of x to the power 4. If you're not sure why, try to multiply this out and you'll see. And once I have this now, one of my two factors is factorable. Not this one, because it has a plus, but this one has a perfect square, and a minus. So this one, and just this one, factors again. And this non-factorable factor just gets copied down on the outside there. And that is the end of factoring difference of squares.